Alright guys, so I wanted to give you guys a video just to help you with remembering like how we evaluate limits, because it has been a little while since we've talked about limits. So first one you want to check is, can I just plug it in? That is ideal. That would be wonderful if it worked every time, but that is not always the case. If you can't just plug it in, can we factor and cancel something? If you can factor and cancel something, then you're likely going to be able to just plug it in. If that doesn't work, you probably are going to want to try L'Hopital's rule. Remember, that only works with 0 over 0 or infinity over infinity. Now, there are some where that doesn't really apply. So if you're looking at something that is a piecewise function, you need to plug it into the left and to the right and see if they are equal. And we'll look at an example of that. If you're dealing with something you know is an asymptote, you're going to need to check the appropriate side to see if it's positive or negative. And again, we'll look at something like that. And if it is a limit as x approaches infinity, that means you are looking for a horizontal asymptote. So is it top heavy, meaning there is going to be an answer of positive or negative infinity? Is it bottom heavy, which means the answer is going to be 0? Or is it balanced, where you would look at the fraction of the leading coefficients? So let's run through just a couple examples of evaluating limits just to make sure we're kind of all on the same page. So the limit as x approaches 1 of negative x minus 4 over x squared minus 6x plus 8. So our first step really is we just want to see, can we plug it in? So if we go to try to plug that in, we get negative 1 minus 4 is negative 3. Then we'll have 1 minus 6 plus 8. So that is going to give us 9 minus 6, which is 3. We didn't have any issues with it, meaning we were just able to plug it in. Negative, negative makes it positive 1. So we're done with that. Now that is not the case for most of the limit questions that we do. So limit as x approaches negative 3 of x squared plus 2x minus 3 is on bottom, and then x plus 3 is on top. So what we would want to check first is, can we just plug it in? So if we plug it in, on top we get 0. On bottom we get 9 minus 6 minus 3, which is also 0. Now technically here you can use L'Hopital's rule, but I'm going to ignore that. What I'm going to do is skip over L'Hopital's and factor. So if I factor that denominator, it's got to be an x. That's a negative, so one has to be positive, one has to be negative. 3 is only 1 in 3, so we want it to be positive 2. So those are going to cancel, and that simplifies down to 1 over x minus 1. So now you can plug it in, and you're going to get negative 1/4. If you did L'Hopital's rule with it, you would end up with the same thing, because you would have the derivative on the top is 1. The derivative on the bottom is 2x plus 2. And so you would plug in negative 3, and you would still end up with that negative 1/4. So this factor and cancel, or the L'Hopital's rule, can really kind of be used interchangeably. So piecewise function. So the limit as x approaches negative 2 from the right of 3x over x plus 2. Now, how do you know this is an asymptote? Well, if you plug in negative 2, you get 0 on the bottom, but you don't get 0 on top. So it's not a L'Hopital's situation. It's just a situation where your answer is going to either be positive infinity or negative infinity. So we are looking at values that are approaching negative 2 from the right side. So just a quick number line here. So we're trying to find the limit at negative 2, but we are approaching from the right side. So that means we need to pick a number on the right side of it to see if it comes out positive or negative. I like to pick the thing that's closest to it. So if we try negative 1, we get negative 3 over 1. which is a negative number. So that means our limit is approaching negative infinity. If we tried something from the left, so like -3, we would end up with -9 over -1, which is positive, and that would mean it would be approaching infinity. So you're just looking to see what is it doing on that side. Now last type, limit as x approaches infinity of square root of 2x squared plus 1 over 4x plus 2. So anytime you see this right here, limit as x approaches infinity, you need to automatically think you're trying to find a horizontal asymptote. So you are really just looking at the leading coefficients in this. So here is your leading coefficient on top, here's your leading coefficient on bottom. Now the issue with the top is that it's underneath a square root. So on top, really what you're looking at, you can't take the square root of 2 and then the square root of x squared is x. On bottom, what you're looking at is that 4x. So we look and see these powers are the same, so that means it's balanced. So we do the fraction of the leading coefficients, and you get the square root of 2 over 4. So that should kind of cover your bases on evaluating limits. I didn't talk about it with using graphs, but when you look at a graph, basically you're wanting to see, does it approach the same thing from the right and the left? So it doesn't matter if it's a sharp curve or what. We just want to see, does it approach the same thing? So like here, the limit exists because it approaches the same thing from the left and from the right. If it had been an open circle, it would still exist because it's approaching the same thing. Here, however, it does not exist because we're approaching something different from the left and from the right. So if you've got any other questions when you're looking at your limit stuff, we can talk in the Google Hangouts later, or you can text me via Remind and we can try to get it figured out. Thanks, guys.